welcome to today's webinar. So my name is James Edwards and I'll be running the webinar for today. The presentation today will utilise the latest versions of Leapfrog Geo 5.0 and Central 2.2. The webinar is primarily designed for new users to our software suite, but it will hold some valuable information for existing Leapfrog modelers as well. And basically today we're going to be introducing Seequent as a company and discussing how we support our clients to address some of the common technical challenges we find in the industrial minerals industry. The second half of the presentation will be a live demonstration of our products, and it's going to help you to understand the concepts that we're discussing today. So let's get started. So who are we? Some of you may have heard of Seequent, others may be more familiar with the name of our products, such as Leapfrog Geo. In essence, we're a software company, but where we differ is that from the very beginning, we've understood that the context is the key to connecting the right information, give us the right insights to make the right decisions. Our vision is to enable better decisions about Earth, environment, and energy challenges. We find our customers are tackling some of the world's most challenging problems using not just our software, but also the technical advice and expertise our global team of industry experts can provide. Above all, we believe in constant innovation, both for us and the businesses we support. By working in partnership, we ensure we stay at the forefront of innovation and consistently add value back into the work our clients undertake. So not trying to state the obvious for those on the call, but we do understand that the industrial minerals sector can often be misperceived or misunderstood. People rarely understand or at least underestimate the multiple uses and requirements of markets for industrial minerals, where quality control of production, product consistency, and customer relationships are paramount to ensure a sustainable, profitable business. Demand is driven by the market, therefore product quality and consistency is essential and drives acceptance. Equally, funneling the demand requires building customer relationships, which are formed on credibility, reliability, and mutual support. And we probably shouldn't underestimate in the current climate, obtaining a license to operate from local communities will become a bigger issue. Having the right tools to communicate and share information will support community relationships and building. So how easy would life be if you knew exactly what was in the ground and exactly where it was? Now, while we might never be able to achieve exactly that, what we typically find at the moment is that the journey of developing resource insight from exploration through to short-term mine planning is often scattered across organizational boundaries, different data sources, and different geological models. We see processes and procedures at one site can often be in complete contrast to another. And not only does this lack of standardization drive inefficiencies in your business, where best practice does exist, it is often not recognized and therefore isn't shared across the company. When you work in an industry that is as market and customer driven as yours, you obviously need to be reactive to changing demand. Contracts are specific and relationships are built on the reliable supply of material to meet customer needs. So how quickly can you currently react? And how much certainty do you have in those decisions? You can't change the natural variability of a deposit. But by increasing the knowledge of your resource base, you can reduce uncertainty and move forwards with greater confidence. And with greater confidence, you can get an improved understanding of your resources. For example, with a better understanding, can you help to redefine waste to something more marketable? And potentially with less waste, obviously it would drive down operational costs. So what do we offer? We'll take a look at what Seequent has and then also how we believe we can support your business to extract maximum value from the resources you have and address the challenges within the industry. So Seequent currently offers solutions to several industries that, whilst diverse, will gain value from a greater insight into what is below the ground. For the industrial minerals sector, our mining product suite covers all aspects of the exploration and mine lifecycle. The products are focused around our central data management platform. So Central helps you visualize, track, and manage your geological data from a centralized, auditable environment. It brings project teams together, helps stay connected, and enables your team to make confident decisions when it matters the most. Deposit is the only true software as a solution of its kind, offering affordability and flexibility. It comes with both mobile and web-based login and data management tools with on-the-spot validation. So anywhere that you're drilling or collecting samples, then Deposit can make the process easier for you. Leapfrog sets a standard in geological modeling and reduces risk by creating more time and opportunity to understand the geology. Leapfrog Geo is our flagship application, which harnesses the power of implicit modeling to build and update models significantly faster. And integrated with Geo is our estimation software package, Edge. So Edge is a natural progression from Geo's traditional geological modeling into the resource estimation space. We find when Edge is used together with Leapfrog Geo, the solution marries robust understanding of the geology with sound resource domain and defensible variography and estimates. We also have Geosoft's technology platform, which is an industry standard within the geosciences. Within Geosoft packages, Target for ArcGIS software is regarded as the market-leading geological application for Esri. So it delivers essential workflows for geoscientists and GIS professionals working in the ArcGIS platform. And lastly, Geoslope provides geotechnical and environmental engineers with rigorous analytical capability to solve diverse geotechnical and geoscience problems. Geoslope helps users work across a broad range of engineering use cases, including excavations and open pit mining. So how are we different? But depending on your size, complexity, and need, there's a combination of products that will enable you to extract maximum value from your data. The integrated nature of our products and ease of use will help break down barriers across your operations. The software doesn't require years of experience to drive the desired result. It follows a logical workflow that has been designed by geologists and in partnership with major industry clients. Our central platform, which we're going to have a look at in the demonstration, provides a collaborative and connected environment. Before Central, we found that the majority of our customers would use PDFs, PowerPoints, or printouts to try and convey key information about their models. Often impacts of changes would be discussed by moving between different bits of paper. With Central, they have these discussions around the data in 3D. Even if remotely, they can have it between sites and office via the online platform. Opinions, decisions, and knowledge can be captured in 3D and preserved for future consideration. And Central also helps drive standardization and ensures data is secure, available, and auditable. Our implicit modeling engine and dynamic updating enables you to update your models in hours rather than weeks. We also have clients, one of our clients, for example, has over 1,000 veins in their model, and we found updates were limited to at least once a year, and no sooner had one resource model been completed, the next one would start. With Leapfrog Geo, they can now incorporate new data on a weekly basis. Through this, they can adjust their short-term plan to account for changes in the resource base, ensuring that they're extracting maximum value from what's in the ground. And not only that, so being able to update your models rapidly presents the opportunity to work differently. If inclusion of data isn't your bottleneck, can you sample more frequently? Could drill campaigns be executed differently? Could areas of risk be managed smarter? Our products will help you better define the chemical and physical characteristics of your deposit. The integration of geological information into one better universal source of truth helps optimize operations, create an executable mine plan, and avoid quality issues at the source. And with the insight gained from having the latest data available to you, your model can move from reactive to proactive. And being proactive allows you to combine business strategy with resource knowledge and deliver a high quality, consistent product for your customer base. Now, one of the best cases or examples we have, I don't know if you've seen the Lhoist case study. It's been sent out in some of the material we've distributed recently. Lhoist are a great example where using our products has driven collaboration across technical teams and radically improved their workflows. They've moved from a reactive model to one where data is incorporated into the model on a daily basis. And this provides Lhoist with a predictability of impurities and contaminants before they blast. What they found is the ability to know exactly what they can supply to customers puts their business in a position of strength. So to know exact quality at specific locations in the quarry allow them to plan to ensure that they meet the needs of their customers. And with more confidence in their data, it provides agility in decision making. An easier way to explain this is a short 30-second clip that we made in partnership with Lhoist.
As a company is motivated to introduce innovation that keep us as efficient and sustainable as possible. And it was this motivation that led us to Seequent. By working together, we've been able to radically improve our workflow to enable a much richer relationship with our geology.
We have more confidence in our data, and it gives us agility in decision making, and ultimately enables us to update our model far more frequently.
So you've heard me use the term implicit modeling and RBF functions a few times. For those who are not familiar with these terms, I'll have a try at providing a brief overview. But again, what you'll probably see in the demonstration will help make a lot more sense. So in the implicit world, one of the fundamental changes is we don't just wireframe and force a model into our interpretation. We work with the data to make the best decisions possible using both statistics and geological expertise. So I'll try and start by explaining the fundamental differences between the two methods. And first off, we'll look at the explicit method first. So quite frequently, a modeler in an explicit software program is hit by several major challenges. One, for example, is that explicit software packages are not particularly intuitive and it can take years to become truly proficient. Commonly, the geologist has to work in a 2D environment where data is heavily restricted to sections, and it's up to the modeler's expertise to interpret how that data is connected in the black spaces in between. For anyone not knowing what wireframing is, modeling has to go through a painstaking exercise of digitizing every single point, and then they need to connect each of them via strings. These strings then sit on sections, which in turn are then connected into the 3D space to create a volume. This exercise has to be carried out for each litho unit, and the modeler has to make sure that each volume fits the next one perfectly to create an airtight model without intersections. Now try and imagine what happens once new data is added into that model. The whole process of digitizing and local section interpretation starts over, and not just for that one volume, but for all the adjoining ones as well. And this, of course, results in just a ton of extra work. So from this perspective, it's not surprising that explicitly derived models tend to contain only one level of geological interpretation that may or may not respect other collected drill hole data, such as structural, geochemical, or geophysical measurements. Now, implicit software takes a completely different approach to 3D modeling, as it's based on the mathematical evaluation of data in combination with skilled interpretation. Key to this is you have full control to make the changes necessary to develop a true geological interpretation that also takes advantage of a statistically sound base model. And the great news is that it won't take long to learn, as the software is intuitive and is created by geologists for geologists. In addition, it allows you to integrate more than one data set and quickly develop several levels of interpretation within one project. Probably best of all is whenever there's a new stream of data coming in, the dynamic link between the data source and the final model allows for your interpretations to be updated almost instantly, without the painstaking process of digitizing every new data point. Therefore, because of the way the software is set up, modeling becomes an objective exercise, and the model's reproducibility allows for a clear and auditable reporting process. Now, again, I'm not sure how clear that explanation was, but you'll definitely see evidence of that during the demonstration. But to be fair, that's probably enough of the talking, so we'll have a look at some of this in action. And what we're going to have a look at today is a simple limestone model. The intention is to provide you with a quick look at how the software works and maybe give you some ideas how this could add value to operations. It's definitely not exhaustive, and I'd be more than happy to follow this up with a more detailed demonstration in future. We're going to start the demonstration in Central Browser, where we'll review the model history. And then we're going to switch into Geo, where we're going to build the geological model, create some contaminant shells, and then we'll look at taking this one step further and build a block model, and then use an edge estimate our calcium oxide values. We'll then finish with a demonstration of the dynamic update capability. Now, for those of you that have worked in the explicit world, you'll understand quite how much work that potentially would be to run through in a 20-minute demonstration. Okay, so let's jump into Central Browser. So this is the first screen you'd see in Central Browser. And as I mentioned earlier, Central helps you to visualize, track, and manage your 3D geological data. On the left here, you can see a list of the different servers I currently have access to. And on the right, there's several thumbnails which represent individual models. So these basically act as like a placeholder for all the data and information associated with that individual model. For today's demonstration, I'm going to jump into the IM demo model here. And what you can see in this screen is a simple view of the complete history of this model, what has taken place on the project over time, and who has made those changes. Now, this is something you can't really see, or is at least very complex to understand without Central. On the left-hand side here, you can see a number of nodes. So each node effectively records a key change or decision point. And as each node preserves the complete model and metadata at that point in time, you can just jump back to any location and review or discuss it in 3D. Give you a quick example. If we look at this, so model 257 here, you can see is associated with this node. So you can see it was myself that uploaded it and what had changed in that model at the time. On the right-hand side, there's a number of additional bits of data or metadata. So you can see some of the information around the software version, say who the modeler was, when it was updated. Also some of the metadata. And this is particularly key in things like if you have a resource estimation or a model here where you want to be able to preserve a snapshot of the key files such as surveys or topography, any other information that goes with that resource model can be all linked on the right-hand side here. Moving slightly further across, you can see the annotations. So if you remember in some of the earlier slides, we talked about how Central can become a collaborative platform. So not only is it good for viewing your data, it also allows you to work with colleagues that don't have to be necessarily located in the same office. So your colleagues can pick up the models in Central and they can review them in 3D. They can turn features on and off, which we'll have a look at in a second. But best of all, they can also make annotations and comments in 3D space on your model. So if you have a peer review process, for example, and your peer reviewer might be sitting somewhere else, they can run through the model, make their comments and provide their feedback that's then available for you to pick up and carry on working with. And key to kind of preserving that continuity and that auditability is all those comments are then also preserved against that model. So if we look at the annotations on the right-hand side here, you can see one of my colleagues here, Eggerman, has looked through the model and decided at this point, there's an area that looks a bit under-drilled. So as well as recording who's made the comment and when, you can also, it provides you a thumbnail that allows you to jump to that view that my colleague was looking at when he made that comment. So if I click on the thumbnail here, you can see it takes me into the scene tab. So what this is doing is it's loading up the exact view that Eggerman was looking at when he made that comment. And you can see it also geolocates the point he was talking about. Now I can choose at this point to reply to his comment. I might agree with him or disagree. I can also have a look at the model, and maybe if I was reviewing something in section here, I can also add my own comment. So it's very simple. You can go and add it. You can add a location of what you're talking about, and can we make something up for now? So now when my modeler comes back, they'll see the view I was looking at, the hole I was interested in, and what I wanted them to do. On the left-hand side over here, you can see all the objects that are associated with that model. You can turn things on and off. You can load up different features. So we've got the drilling on here currently. I can also go and load some of the volumes of my model. Now if I jump out a section, what you can see is my complete 3D model. And this is what we're going to be recreating during the demonstration today. One of the really nice features in here is that depending on who the other groups are that might be interested in the files that you create or the volumes that you create, they have an option to essentially self-serve. So if you've ever had the situation before where maybe your engineer needs your grade shells or some of your stratigraphy, they would have to go and find the geologist, find the latest version, and work out how to get that sent across to them. With Central, that engineer or mine planner or manager has access to the model. They can come in, they can review the history, so they can be sure they're taking files from the latest version. And then they can come in and find the particular file they want, and it's easy enough to export. So once you export it, you can then export it in a number of different file formats, depending on what maybe you're doing your mine plan or your engineering designs in. Okay, so like I said, what we're going to do, we're going to jump into Geo now, and we're going to recreate this model and then take it a few steps further. There's some really great webinars and a lot more detail around workflows and how you can use Central to really benefit your business. So they're available on both our websites and some of our media channels. So I strongly recommend, if you're interested, to go and watch a couple of those. But for now, we're going to jump into Geo. So if you remember this view, the history of the model, and then we'll go and have a look at Leapfrog Geo in action. So the first page in Leapfrog Geo, you can see I've got that similar list of servers I have access to and the same kind of thumbnails. So you see I'm connected here to my demo server. So I'm going to go into my IM demo model, and I get the same vision or same version of that history of the model that I can pick to work on anything within here. Now, what I've done earlier is I've gone and created a demo model that's had a lot of the current information stripped back out so we can kind of build it up again together. So once I've got this one open, I'm going to jump into my scene view where I do a lot of my work. So this is the Geo Workspace, and straight away you can see it's designed for simplicity, so no sea of buttons and no options to click. On the left you have the project tree, and when you open any project there'll be a standard list of folders and objects in the project tree. This top level list of folders is consistent for all projects, and the way objects are organized in the project tree lets you reveal or hide information about an object to focus just on what you're currently working with. The project tree basically becomes where you import work and build your data. To the right over here is the scene view. This is where the objects appear when they are added from the project tree. And then the big box below is the shape list. And so that's where all the active objects that are in the scene are available for modification. So you can change the properties like color and codes. As I said, so to save some time today, I've pre-populated this particular model with a couple of files. So we have a topography file that I brought in. We have a fault in our model. So you can see down in the southwest here, I have a fault cutting across. And I've also got some drill hole data. So I've got a collar survey, assay, and lith file. And you can see my lith file is just a hole ID from to and geology. In the same way, my assay is a hole ID from to and grades. If we drag those on, let's have a look at our lith initially. So you can see all my drilling. And if I pop up the legend here, you can see I've got an L1 unit running through the middle. And if maybe it'd be easier, actually, I'll pop my fault back on because you can see what's happened down in the southwest here. I've had the C1 unit faulted in. So I have the C1 in the southwest, and then I've got some overburden is my light blue, and then my C1, M1, 2, and 3. In terms of assays, have a look at our calcium, and you can see straight away my high-grade calcium is concentrated through the center of my project here. So often the simplest analysis can give some great insights. Now, it'd be great to be able to see obviously the assay against the lithology. And what we can do here is we can actually merge these two tables. So there's a function in Geo for merge table. So I can choose to merge my assays with my geology. You can see what that's done when that finishes processing is it's taken my two tables and it's taken the same obviously whole ID from and to value, and then it's combined my grades with my geology. Now the neat thing is once I've got that, I can go and look at some of the statistics for my data. So if I jump into statistics and look at the table, for example, first, I can choose to categorize by my geology, and let's have a look at the calcium. So straight away, just from having my data in here, I can very quickly see some of the key statistics around my deposit. I can sort by my mean, and I can see my L1 unit is clearly my high-grade calcium oxide. There's a few other statistical tools in here. For example, box plot might be another one that's of some interest. So again, you can set it up in a similar way. And you can see that L1 unit again stands out as should be my unit of interest if I'm interested in a calcium oxide. So to take it to the next level of analysis, I'm going to go and build my geological model. Let's turn our assays off for a second, and we're going to have a look at our geology. So the first thing we're going to do is we're going to come down to our geological model folder, and we're going to make a new geological model. I'm just going to change a couple of the settings. Like I said, today we're not going through everything in detail. So if we do any follow-ups, we can explain in a lot more information around some of the functions you can use and some of the settings you can apply. But for now, we're just going to build a nice simple model. What that's done is create a number of default folders. With the default folders, it always creates an empty volume. So if I drag that on just initially, you can see based on my topography and the boundaries that I defined, I've got an empty volume that encompasses my deposit. My next task is to basically go and define surfaces that will cut this empty volume up and code it with my respective units. Now the first thing I want to do is use this fault. So I'm going to bring that southern fault into my fault system by creating a new fault from an existing surface. So you can see my southern fault here is highlighted in the available meshes. So I'm going to pick southern fault and click OK. I now have this southern fault in. And now I want to activate that fault to say I want to use that fault to break up my initial volume into two separate fault blocks. So you can see it's gone and created a fault block 1 and a fault block 2. And if we want to see the effects of that, we can load the fault block boundaries, and you can see I now have two separate volumes, one on the southeast and one on, southwest and one on the northeast. Now clearly we know from the statistics that the L1 unit is my one of interest, so we're going to focus on building the geology in this unit first. So first step looking at my geology is I think I'm going to go and create the overburden. So I'm going to come down to my fault block 1 and I'm going to start creating in my surface chronology a new erosion from my lithology pulled from my drilling. My unit of interest is my overburden, and I'm going to use all the contacts below that overburden, so these are all the units of contacts, to define where that surface should go. Once that's created, we can load that on. And you can see pretty instantly, I have a surface that is defined anywhere I've got a contact between overburden and a unit below. This big gap in the middle, as you can see, is because there's no overburden encountered in any of those drill holes. Now, if we chuck this into a section for a second, you can see we've got our overburden on the top, and then we have the L1 unit and a pretty conformable relationship to our M1, M2, M3. So to model this, I can go and use the stratigraphy tool. I'm going to set my top unit as my L1, then my M1, M2, and my M3 below. So again, you can see this requires you to understand the geology of your deposit. You set the rules, and then you allow it to build by defining where those contacts are, and then it models the surface through those contacts. So if we load those on, you can see it's done a pretty good estimation at where my surfaces should go. Now, like I said, this is a fairly simple model, so it probably doesn't need much editing beyond this. But for today's purpose, I think that's pretty good. So now I've got my surfaces defined for fault block 1. What I want to do next is I know I have my empty volume. So I need to tell Leapfrog to use those surfaces to divide this volume up. So I'm going to go into my surface chronology. I'm going to make sure I have my surface chronology in the correct order, so youngest at the top. And then I can choose to activate these to do the cutting. So I can let that run. And what you'll see is that in my output volumes, let's remove these surfaces now. If I drag my volumes on, I now have solid volumes with perfect contacts defining my geology. Now, fault block 2 over here in the southwest has only got one unit in it, so I can very quickly go and say that all that lithology is C1 and allow that to build as well. And that will now give me my final volumes for my geological model. Now again, for those of you who have spent time modeling before, hopefully be able to appreciate both the accuracy and detail within this model, coupled with the speed that we've been able to build that at. Now, now we can get into kind of some of the actual analysis around our data. So we've defined our geology, and now what we're keen to understand is maybe around the distribution of my grades. So we know my L1 unit is the one I'm interested in. So let's go and unload everything else. So I've got an L1 unit here. And it depends, everyone's going to have obviously different parameters or different material quality measurements. In this example here, one of the things that we were interested in was the distribution of iron. So iron was a significant impurity in the products they were producing. So they needed to have a knowledge around what was very low iron for their high quality material, and also where was some of the higher iron for the low quality material. One of the things you can do is a numerical model. Now, if we just hide our volume for a second and we go back and have a look at our assays. So this is our calcium. If we go and have a look at our iron, for example, now you can very easily play around with the legends, the color-coded legends in here to make it however you need. You can change the bin widths and so on. But you can see to try and actually domain out areas of very low iron or very high iron could be quite challenging if you were to try and do this by hand or digitize in strings. But what we can do in Geo is we can go into numerical models and create a new interpolant. So in this case, we're interested in looking at our iron. And because we know our L1 unit is what we're interested in, I'm going to set that as my boundary. So you can see the existing model boundary I'm using is the L1. So that's going to limit my interpretation of my volumes to that one unit. So once I'm happy with that, I can create that model, and then I'm going to go in and specify some of the parameters. Now again, this is kind of all the detail we go through here around compositing drill holes, redefining boundaries, value transformations and trends. We can go through in a lot more detail in person if required. At the moment, the main thing I'm going to be interested in is I want to go and have a look and set some intervals up. So what are the zones I'm interested in? So initially, I want to know everywhere where iron is less than 0.5. I'm also interested in knowing where it's between 0.5 and 0.8, up to 1.5, and then also I'd like to know some of the areas for a particular product that is over 3% iron. So once I got those set up, I can let that run. Now, so what that's done is it's going to basically go and create domains and volumes around each one of those concentrations. So you can see a similar set of default folders that are created. And if we load the volumes on, you can see it's built these volumes within my L1 unit. Now down here, you can see the different volumes that it's created. And if I go and turn off everything apart from my low iron, you can see straight away I can accurately model my zones of high quality material or low iron. Equally, if I was interested to know where some of my low-grade material is, I can model these out as well. Now, this is like a very, very first pass. You'd obviously spend time refining this model, running a few different iterations, and having a look and validating it against your data. So obviously can't emphasize enough the value of putting time into your models once you created these things initially. It's not a case of a one-click and a model's created. You have to put the time in. But the key thing is the time that you're putting in is on the high value tasks of your interpretation and your validation. It's not on the low value add of just clicking buttons and drawing around lines. So we turn all these back on, we can jump into section again, and you can see in section kind of the distribution of your iron values. Now in the same way we looked at with central, this might be something that you can hand over to a mine planner or an engineer or just some of your operations to actually be able to identify specific areas within your pit or your quarry that has areas of significance. So you can model grades, you can model physical properties, whatever it is that is a key driver for your site, you can use numerical models for. Now, once we've done that first pass analysis, which in some cases may be enough for what you're trying to achieve, the next step we'd like to do is understand our resources within our deposit. So to do that, first step is to create a block model. So I'm just going to unload everything again, and I'm going to come down to my block model folders, and I'm going to create a new sub-block model. I'm going to set the parent block size to something that's a bit more realistic for this deposit. So I'm going to set it at 100 by 100 by 10 in the vertical. I'm going to choose how I want this model to be sub-blocked. So in this case, I'm using my geological surfaces to sub-block my model. And the evaluations in Leapfrog Geo is another term for flagging or coding. So what do I want to code these blocks by? So at this point, I'm going to use my geological model to code my blocks. So if I click OK, you can see how quickly I have a block model. You can see it's been coded by my geology. And if we just go and have a look at some of the contacts, you can see some of the sub-blocking that's gone on along those contacts. Okay, step 1 done. Now the next thing we want to do is to estimate resources. We're obviously going to need to build some estimation parameters. So for this, I'm going to come to my estimation folder. I'm going to go and create a new domain estimation. And now I get to specify what's the element I'm interested in and where do I want to model it. So what domain am I interested in? So I know, again, from my initial statistical review or my EDA analysis, I'm interested in the L1 unit for this model. I want to model the CAO, and you can see instantly it gives you a good idea of how your domaining has worked. So in this case, you can see my L1 is a nice hard boundary. I have high-grade calcium oxide inside and dropping almost instantly away to low-grade on the outside of my boundary. If you have a soft boundary, it's easy enough in here. You can go and change the relationship of your model. So once that object's created, what it's basically done is gone and pulled out my L1 domain, which you're probably familiar with that shape now. And it's also gone and basically split out my data or my values from within my complete data set to just being the values within the L1 domain. Once we've got our data, we're going to go and create our spatial model. So if anyone is familiar with resource estimation or has spent time doing it, I apologize in advance for the cringeworthiness of this next couple of minutes, because this is obviously not a detailed statistical analysis or proper variography. I'm just going to go through to show the functionality. Hopefully what you will be able to pick up from it is the ease of use, the simple layout, and again, the dynamic update capability, so you can see the changes you're making and the effect they're having in real time. So we'll initially jump into our radial plot. We'll change a couple of these settings, and you can see every time I'm changing a setting, I'm getting to see the impact of that change as I go along. So I'm going to set in here what I believe my major and my semi-major directions to be. So I'm going to set my major and my semi-major up, and you see that reruns. And then I can go through and model my variography. I can go and change the number of lags to get a bit of a better view. So again, this is not perfect modeling of a variogram, but for today's purposes, I think hopefully you'll forgive me. My semi-major and my minor. And I can also go and have a look. I can either go and add a downhole variogram to maybe have a look at where my nugget should sit. So let's go and set that up around the 10%. Okay, so if I'm happy with how I've modeled my variography, I can save that. Then I can go and define my estimation parameters. So in this case, well, I'm not going to spend much time going into the details of this, but what we will just go and quickly change is maybe set my output. So I'm going to code some of these data, some of the estimation quality measurements into my block model. And maybe we'll have a quick look at setting the update in the search just to be representative of my variogram. Okay, so if I'm happy with that, I now have my variogram model and my estimation parameters. Now, one of the neat things you can do in here is you can go and copy those parameters and apply them to another element. Now, obviously, if you're doing this for real, maybe you'd copy the parameters across, but then you'd go in and update your variography so it's representative of your data. For today's purpose, I want to be able to use some of these elements in an example I'm going to show you on block calculations. So I'm just going to copy them quickly, and say we'll use them in a minute. Okay. So now you can see I have I've got my 4 elements, my statistical models, and my estimation parameters. I can now go back to my block model and to my evaluations, and I can apply all of those estimators onto my block model. If I click OK, what that will do is essentially run that estimation into the block model. So let's turn these off and bring our block model back. So we started with our geology, and now you can see if I do the drop down here, I can choose geology, or now I can choose my estimations as well. So if you remember, we limited our estimation to a particular domain, in this case the L1, which is why we're only looking at the L1 blocks at the moment. So here you can see the calcium estimate, the alumina estimate, iron, and silica. And any one of these blocks you go and click on, it will give you information about that block, the grades, and the estimation parameters. So once you've got your estimate, there's a number of validations you can go and do around swath plots. You can look at grade tonnage graphs. You can go and create resource reports. So you can set up customized resource reports. If we go and have a look, for example, at our geological model and maybe our calcium. Let's just set this up, and we can see our estimation says we have about 66.5 million tons at 43.78. So that's the resource reporting. The other thing we can do in here, which is a nice feature. So again, it depends how you like to, or how you need to calculate material quality. So everything is obviously respective to an individual site and the challenges that you have for your particular product to meet your customer needs. Now, in this case, one of the key ratios was around a silica ratio. So if I go into here, I can go to my calculations and filters, and we're going to have a look at creating a numeric calculation in my block model. I'm going to call this one my silica ratio, and I'm now going to set that up to be silica divided by the sum of alumina plus iron. So you can see here my silica ratio is stating the formula, the silica estimate divided by the alumina estimate plus iron. If I'm happy with that, I can save that. You see it gives me instantly down here a range of my ratios. And if I go back to my block model now, I have an option on my drop down to look per block what the silica ratio is. So the last thing we're going to do as part of this demonstration is we're going to have a look at the feature, one of the key features again that we've talked about during the earlier part of the presentation around the dynamic update capability. Now, what we have in this particular project is we can have a look at our drill holes. Let's look in a plan view. So I have my drill holes here, and you can see that we've got a bit of a gap in our model up in the northwest corner. So what we've done is they've gone out and they've drilled about 15, 20 new holes to fill in that area. Now, what I want to do with this is I want to bring that data into my model. Now, in an explicit model, you'd bring that data in. You'd bring that data in, and you'd have to go and redigitize all your strings, go and recreate all your wireframes, rebuild your models, rebuild your block models, and that process would essentially take almost as long as the original model did. Now, admittedly, this model has been pretty quick, but what we're going to see is if I go into my drill holes, I'm going to go and find that second phase of drilling. So I'm going to go append that to my current database. I'm going to search for my data. So in this case, I've got my collar phase 2 drilling here. I'll open this one up. So one of the things Geo does is it searches by name. So if it finds anything with a similar name, it will go and pre-populate your survey and your interval tables. You can obviously go and change that, but it's just a nice feature to, again, hopefully get you moving a bit quicker. So if I import that data, it runs through my drill hole importer. These have already been pre-set up by the initial import of the data when I first set the model up. So I can run through these because I know they're all the same. And what it's going to do now is it's going to basically rerun everything. So the way Geo works is that kind of at the top of your tree is your drill hole data. So that is your key your cornerstone piece of information. Everything else you do in this example here is built off that drill hole data. So if you add new data to your drill holes, it's going to flow through and rebuild your model based on the rules and parameters you defined. It's then going to go and rebuild your block model, rerun your estimation parameters, and essentially all the way through to the resource report. So you can see here in the case of the silica ratio, adding that new drilling has dropped my silica ratio in this area. If we go and have a look at the resource report, you can see my tonnage has gone up, and I think my grades dropped slightly. But basically in the time it took me to explain what I was actually trying to do, I've managed to rebuild the whole model, re-estimate, and re-report. Now, what we kind of mentioned earlier, obviously that doesn't take away from the fact that if you're doing this in the real world, bringing any new data into a project still requires the initial validation and the post-validation. So once all of that's rerun, it's imperative that the geologist goes back and has a look in 3D at the impact of that data to make sure that it is still true to what you believe should happen, or it still makes some geological sense. So essentially the last thing we would normally do with this is we've made a significant change. We've added some new data in. So if we'd done this, we'd go down and we'd publish this model back up to Central. And that publishing process is pretty straightforward and nice and quick. In here, you can pick the objects you want to be available for other people to view. So in this case, we might just say, well, look, I've made a change to my block model and my geological model by bringing in my new lithology and assay table. I'll leave this stuff for now. And like I say, more than happy to go through more detail with you in person anytime after this. And you'd add a comment onto why you're loading this or why you're publishing this new version up. So in this case, we have some additional drilling. And once you've done that, you can click Next. It's going to run through a process of basically collecting the data. It has a look at what's already in Central, so what was the previous version, and it looks at what's changed in your current model. So anything that's changed, it basically now packages up, posts up to the Central server, and it's now available as a new node on that tree for essentially anyone to go and have a look at. Now, if you wanted to be able to just show somebody the model or provide it to them to look at, so it could be, again, management, external stakeholders. It might be you just want to take it out with you on your phone or an iPad into the pit. You can also publish the view, so in 3D with the functionality of spinning it around and turning things on and off in our view application. So view application is completely free and it's web-based. So there's an option up in the top corner here where you can choose to publish a view. And if you upload that, it basically runs and provides you with a web link, and that web link can then be provided to any other user or any other person. It doesn't have to be a user of Geo. They don't need any particular software. They just need to be able to use a web link and have an active connection. So you can see here, in this case, I can get the address and I could send that address on. Okay, so that's pretty much all the initial features I wanted to show you. Like I said, that was a very high level, quite quick run through, but just to see some of the capability of the program and kind of hopefully visualize some of the features that I was talking about in the earlier part of the presentation. Hopefully the main takeaways you get from this is obviously the ease of use, the speed that you can model and update, and the dynamic capability of adding new data into your model.